Okay, hopefully I can record this without too many interruptions in the background. You may hear a bird or children. Hopefully that's okay. 3 randomly selected households are surveyed. The number of people in the households are 2, 3, and 10. Assume that the samples that your sampling of size 2 randomly selected with replacement from that population. So we're imagining that that's the entire population of some given group you want to talk about. It was just those 3 households. Maybe it's the 3 households that are on the moon, and there only has been 3 created, so it's those. Listed below are 9 different samples, and then it's a complete parts A through C. Okay, so they've actually created all these, but I think it's no small thing to come up with this, and I just want to make sure, if you didn't see my other video that doesn't have audio, I'm going to say it to you here and just re-point this out. Since there's 3 households or 3 numbers, we just like to put them in order. This is pretty typical. We put them in order of the smallest to the greatest, and then we sample them this way. If the sampling is size 2, we take the first one, and then with replacement, so we throw it back into the group of 3, and imagine that we picked it again. So that would be 2, and then picking 2 again. Then we do 2, and then pick 3, 2, and then pick 10. Again, it's with replacement, so when we pick 3, imagine fixing 3 and seeing all the possibilities for 3. You could pick 3, and then you could pick 2. You could pick 3, then 3, then 3, then 10. And so these 9 come from the fact that you're filling 2 positions with 3 population items. And if they had made this a population size 5, what would the total sampling be? It would be 5 times 5, right? Because it's 2 spaces where they're going to fill in. And by the way, this counting stuff, the multiplication rule that I'm actually discussing right here without saying the name, well, now I've said it, it comes from chapter 4. So that would be 5 squared, 25. Now they're not making it that hard on us, but you might be able to see it go as high as 16. That would be 4 population items and sampling of size 2. So 4 times 4. And just in case they do bring it up, I can't remember that they have, but we could have had 4 items, and then sampling size 3. Now that would give you 4 times 4 times 4, which would be 64 items. So think about how nice they made our life. All right, now let me go ahead and just open this in StatCrunch. You can do a similar thing here in Excel or StatDisk or the TI calculator. All right, we're going to utilize the Stat menu, Summary Statistics by row. And when you select these, we're going to select where the data is, and that is rows 1 and 2. Columns x1, x2. You have to hold Control when you click the other one, or hold Shift, but you want to select both of them. So like if I select sample and then I select anything else just by clicking, it only selects that one thing. But if I select one of them and hold Shift and then select another one, it'll select all of the ones using Shift. Or single items, I can hit Control and select anything to either toggle on or off those items. Does that make sense? Well, you can't answer me, so I'm going to assume it does. So then we go on, and we don't need all this information. What we just need is, for this question, is the variance. Remember, we could do all of this by hand, and that would be using the formula sheet. To find sample variance, you find out the median. So for that first example, if the numbers are 2 and 2, the average between 2 and 2 is 2. And then you find the deviations. Well, 2 minus 2 is 0. That's the deviation. Square 0, it's 0 still. And then do that again for the other item, but it's still 2. So you get 2 zeros. You add those 2 zeros together. That's the sum of 0 plus 0. And then that's 0 divided by 2 items minus 1 is 1. So 0 divided by 1 is 1, which is still 0. And that is all you need to do. You don't do the square root part. Because remember that the sample variance is the sample standard deviation, which is this formula right here, squared. Because it's the thing inside the root before you take the square root. All right, but we're not going to worry about any of that. In fact, I'm going to do all this extra information, and I'm just going to run it all. Okay, so what you see here is it's gone down row by row and used those as your 2 items, and it found the standard deviation there, and you can see it right here, and I'm sorry, and the variance. There's the variance right there, 0. That's the one I said verbally, and then here's the others. So when you go to put them in, though, these are empty, right? And the reason why these are empty and you have to drop down is because, first of all, you got to recognize what kind of variances you're going to have and how many are going to be the same, how many are going to be different. We'll look at the list. Actually, check this out. If you go edit, options edit, you can say that you want to store it in there. And this time I'm going to be a little less distracting with all the extra information. I'm just going to choose variance. So I'm going to store this right back into my table. You can rewind and pause on any of these things I'm showing you. Okay, and so now I can see there's my samples, and here are my possible variances. And how many times are these going to show up? Well, because there's 9 items, they each show up 1/9, right? But since some of them are duplicated, and I'll just demonstrate right here, I see 0, and it's actually duplicated 3 times, so that's going to be 3 times out of 9 it'll show up. In other words, 1/3. And I'll simplify that before I actually put it in. My next variance, 0.5, and then let's see, that that shows up twice. We have a 24.5. Is that correct? Oh, I guess we did have that 10, didn't we? Shows up 2 times, and then just that 32 left, it looks like. Shows up 3 times. Now, since this is a probability distribution that I'm creating where these are my random variables, so to speak, right? These are the number of variance options that I have. Unique variance options. I know that the 0 showed up 3 times, but uniquely there's just 1 0 as a number, and there's a 3/9 probability of that happening. Okay, since it is a probability distribution, the sum of the probabilities over here should add to be 1, and I left them in fractional form, and I left them in ninths because it makes it easy to see this. This is going to be 3, 4, 5, 6, 7, 8, 9, 9 ninths, and I see now that I have a probability distribution. By the way, if you don't remember that, that is something that we learned in chapter 5. Okay? So you want to redo chapter 5 for that. All right, and that should be the distribution that they show right here. Let me see if I can pull it over. So they've got 0, 0.5, you said 1. Not sure, let's see. So just check your calculations when you did it, if you were doing it by hand. And then all the rest. And then 3/9, it says, oh, you said 1/2. I was going to say it would have probably also taken 1/3. Let me see if it, type an integer or a fraction. Use ascending order for the sample variances, which we already did, and that came out pretty naturally. It doesn't say that I can't use 1/3, and that's what I would have put in. But don't, I do suggest don't simplify it to something like 0.33, because 0.33 is not the same thing as 1/3. Neither is 0.333, neither is 0.3333333. 1/3 would be 0.3 repeated forever. So that's a big issue. And so to keep accuracy, keep it like that, or put 3/9. All right, there's your sampling distribution of sample variances. Now what we want to do is take this sampling distribution of sample variances, and we want to find the mean from it. Now I'll go back to my table. It's similar to when we found right here the mean from a frequency table, where we multiplied the midpoints times the frequencies. We added up all those products, and then we divided by the sum of the frequencies. Except for if you're using probability, that sum of frequencies, the n value, is already accounted for contained in the probability, because the probability is like 3/9, for example, so that the sum of the frequencies, 9, is already counted for. So we change that formula to say that you can simply just multiply each random variable by its probability, get all those numbers, and then you can add that up. Now in StatCrunch, you've got a couple options here to do that. One option is I can create I'll use data here, to create an expression where I build it out of the items in column variable 6 times column variable 7, and hit OK. And I can relabel that. I can call that x times p of x just for aesthetics. It doesn't support this. Oh, maybe it doesn't want me to say that. Maybe it doesn't want me to say that. Okay. Maybe it doesn't see these as numbers, and that's my problem. So let me try this. So this is a little bit disappointing. I'll just go ahead and rename it here. It does not have the ability to use the fractional form of those numbers. Not that I know of. Maybe there's something else I should have done differently. So I approximated that 1/3 to 0.3, and then just held 3 down for a while, and then 0.2 for the 2/9, and so on, and 2/9. Anyway, so here are those sums, and like the sheet says, you find those sums, you find those products, and then you sum them up. So here are the products, and let's see. I think I should also be able to sum those up with a little computation. It did not let me. StatCrunch is acting a little fickle, so I'm just going to go ahead and add these up with a basic calculator. I'm just holding down as many digits as the display will accept. Okay, so I've got 12 and 2/3. 12.6666. Okay, so let's go back to our problem. And that is the mean of this distribution. Okay, now it says, compare the population variance to the mean of the sample variances. Okay, population variance would be found by actually running the three numbers 2, 3, 10, and finding the population variance. So, finding the median, find the mean, subtracting each of those, getting the deviations, squaring each of those, essentially doing all of that which is inside the radical for the standard deviation. I'm going to do that. I'm sorry, I just made a very big mistake. Let me scratch what I just said. This is the sample standard deviation. So if you're doing that, you don't do all of that. You use a capital N down here, and you use a mu right here. So the notation changes, but so does the formula. You don't have to subtract 1, and that was that whole thing we talked about in chapter 3, so I'm not going to go into it here. So the formula is a little bit differently. Let me go ahead and grab that formula from the book and remind you the page. All right, that was page 101, and here it is, reminding us that it's an n when you're doing the population standard deviation, not the n-1, and there's an explanation for it in the back of that chapter for more details about why one has n, one has n-1. But remember, the main concepts of standard deviation is that you're finding all the deviations, how far each data point spreads away or expands away from the mean, and then you're finding the average of all those deviations. So it's the average deviation is what it really is. And it makes more sense in the population calculation because it's really like taking all those deviations, adding them up, and then dividing by n. The whole squaring thing was so that we could avoid negatives, because otherwise you add up and it would always make a 0. Okay, sorry. I can't help but try to emphasize how standard deviation works. Getting back to this. Okay, so let me get the numbers then. I'll open StatCrunch again and put in numbers 2, 3, and 10. Stat, summary statistics, column this time. And it's just that one column. I can run them all. Just pull out what I need. So there's those 3 numbers, the full population. and it has the standard deviation. Oh, I should be careful. I'm not sure if it's giving me the, yeah, it says summary statistics here. So it's assuming that this is a sample. Interesting, I hadn't thought about that. I'll open Excel and I'll make a comparison. You may recall, or not, or if you don't, here's the word. You can find standard deviation for the population or standard deviation for the sample, so the statistic or the parameter. In other words, right here this would be S when you use the notation. That S right there is for statistic or for sample. And then the one right here would be sigma, right? Thinking about the symbols page. Okay, so I'm going to choose that. And sorry, I did not hit tab. So standard deviation for that set, and that's 3.55. So because I'm only in this case dividing by n, which is a bigger number. So the, let's see, where is, oh, and I'm all over the place. I want that squared. Okay, so you'll see that, and in fact, there probably would have been a direct calculation for that. Let's see if there's a direct calculation. Variance, maybe? Var, yep, var. And so then I could have selected that and done it directly. Okay, 12.66, which the important part here is that it turns out to be 12.6666. It's the same number, and that is not surprising at all when we understood or when we read section 6.4. So since variance is an unbiased estimator, it targets the population parameter, that statistics should match. Let me go back to what I had on the StatCrunch screen. On the StatCrunch screen, I had 4.35 because notice that this says summary statistic, and it's using the sample calculation, the sample variance. And so it says 19, it doesn't say 12.6, whatever. And I'm not entirely sure if you can do the population calculation with this. There's got to be a way, I just haven't looked it up. Okay, so the option here is the population variance is equal to the mean of the sample variances. Review the video and see again how we got, oops, this number right here. By doing this, getting the expected mean from a probability distribution that we had created already up here. And again, you could have done all this by hand by multiplying and then adding. Okay, the last part of the question, and I'm sorry this has gone long. Do the sample variance target the value of the population variance? Well, yeah, obviously. In general, do sample variances make good estimators? Yes, and really you shouldn't be able to make that conclusion from one example, but they're assuming that this example reminds you of what you already read. So let me actually go to the PowerPoint for this. Here is a table 6-7 that used to be in our book in the 10th edition, and it really just lays it all together and does all of the examples for a set 1, 2, 5, and shows you that when you create probability distributions from sampling distributions of sample means, sample medians, sample ranges, sample variances, sample standard deviations, and sample proportions, and then calculate the mean, from those probability distributions put down right here, they will, in some instances, target the population parameter. And so right here, this is mu sub x bar, and this right here is actually mu. Right here, this is mu sub x tilde, and this is x tilde for the population. It's the population median. And the ones that target are the sample distribution of means, variance, and proportion. And the others do not. In fact, I'll just show you that summary. It's right here. So some are biased estimators and some are unbiased estimators. And that homework question we were just looking at was to show us that variance is an unbiased estimator. It targets the population. All right, probably could have stopped earlier, but that should be a pretty good explanation of that question. And while I'm in here, I might just be making a little change. All right, thank you very much.